Okay, so this is the 2015 Leaving Cert High Level Physics paper, question 6. Got some stuff about satellites and gravity. Explain what is meant by centripetal force. Okay, so centripetal force, or centripetal if you want, is the force directed towards center of a circle. Probably didn't need that. That's fine. That is needed to keep a body, spherical chickens in space, a body moving in a circular path or circular motion, I think it says in the marking scheme. Centripetal force is the force directed towards the center of a circle that is needed to keep a body moving in a circular motion. Probably didn't need the directed towards the center of the circle bit, but it is. State Newton's laws of universal gravitation. Law, singular. Okay, these are always better when we use just a formula. So the force due to gravity is the universal gravitational constant, the product of the two masses divided by the distance between them squared. And then we have to tell them what everything is. This is the force due to gravity. Big G is the universal gravitational constant. I think it's gravitational constant. M1 is the mass of the first body. We can almost like saying M2 is the mass of the second body, and or is the distance between the bodies. That needs to be in meters if you want to do this right. Kilograms, I can't remember, and newtons. Derived relationship between the period of a satellite. Okay, so on to part 3. The period of a satellite, the radius of its orbit, and the mass of the Earth, big M. Oh, this is the one that t squared and r cubed. Okay, cool. Right, so we know that centripetal force is equal to the gravitational force. How does this work again? So we say mv squared over r is going to be equal to gm m over r squared. Right, so the force due to gravity, say the mass of the Earth and the mass of your satellite, is the same as the centripetal force. The centripetal force depends on the speed and the radius. Okay, and we want to know the period. And what's the link? How do we get period in here again? Because period is distance 2 pi r divided by speed, v. All right, and we have a v squared. Is that right? Yeah, so I can rearrange this and say that v is 2 pi r over t squared. Is that what I want to do? This looks like it might not work. Let's try it. Over t. And therefore v squared is 4 pi squared r squared over t squared. Now I'm going to substitute this back in for my t squared up here. Okay, so I have, do you know what I look? I've got an m on both sides, small m, that can be, I can divide both sides by m. So my v squared is 4 pi squared r squared over t squared, and then there is an or there as well, isn't there, from here? Yeah, is equal to g big M over r squared. I did something wrong. I after doing wrong here? Period. 2 pi over speed. Distance over speed. Grand. No, I didn't. That's fine. I want to be able to link t to everything else. Okay, so that or can divide in and get rid of the squared there. I'm going to multiply both sides by t. Okay, so 4 pi squared or is equal to t squared gm over or squared. Geez, I've lost you guys. Jesus, how long have I been doing that? I've been sitting there. Oh, sorry about that. Okay, what do we miss? So I know that the period of a satellite, the time it takes, is the distance divided by the speed. Rearranging it in terms of v, and then getting v squared because there's a v squared up here. Okay, and I need to get rid of that v squared. I don't want to know what that is. I did that, and then what I did was I substituted this v squared into this formula here. Wherever there was a v squared, I replaced it with 4 pi squared or squared over t squared. That gave me this. Then I realized that the or on the bottom here can divide into the or squared that came from here. Then I multiplied both sides by t squared, and that's where I am right now. And then divide by gm and multiply by or squared. And that will let me end up with 4 pi squared or cubed, because of an or multiplied by an or squared, divided by a g divided by an m is equal to t squared. There we go, done.